before going on break.
Leave. Okay. You want to look into the chi-square definitions?
Yeah. Just leave it screen on. Yeah. Whenever you're leaving, just above. Yeah. Just leave your screen there whenever you.
All right.
Thank
no
you.
issues. I'll do that. Clear?
Yeah. Thank you.
All right. Guys, can you see my screen now? I mean, I hope it's frozen, but you're able to see it, right? Turn on your mic. Just tell me.
Yes.
All right. The first part of the question, like I've already told you, I've got 200 users, 200 credit card users who were part of the last campaign conducted by one of the major bank credit card division. So they would like to test the following hypothesis based on the data. What is our data here? Let's look at that first. This is my data. Like I've told you, I have my cust ID, sex, acquisition channel, region, marital status, segment. These are the demographic information that I have. Agreed? Pre-usage, as in before the campaign, what was the usage? Post-usage first month. After the campaign is run, after 1 month of the campaign is being run, what is the usage? Latest month usage. Post-usage second month. 2 months after the campaign, latest month usage as in what is the current month usage? Clear? Please look at the first question. The first question says that the statement of the first question is the card usage has improved significantly from last year. That's the first question. The sample size is 200, Prerna. I said right, 200 credit card users. So the first question is, card usage has been improved significantly from last year, which was 50. Last year it was 50. This year it has been improved, right? What do you have to do? You have to first find out what's the spend of 200 customers this year. Yes or no? So what do we calculate? We calculate the average of which column here? If I talk about this year, present year usage, and compare it with last year usage, which column should I take into consideration? Latest month. Fantastic. So what's the average of latest month here? We have got 63.17. So it is 63.17. What was last year? 50. What are we trying to prove here? Is this 63.17 significantly different from 50 or not? I hope you're able to understand what I'm saying, right? So here listen please. So here the value here is how much? 50, right? This value is 50. I'm trying to prove whether the new value represented by this blue line is significantly different from this line or not. Which means, is this here closer to this, or is this here far than this? Right? So what do I have to have? I have to set few points here, right? Few points as my cutoff points. Yes or no? If these are my cutoff points. If a blue line lies beyond this cutoff point, which means it's significantly different. here, which means it is significantly same. If it is significantly different from last year, what does that mean? There has been an improvement in the credit card usage than last year, right? Plus, I'm assuming that the entire thing, my entire data is normally distributed. That's my first assumption. I'll go with that. Clear? Yes? Now, what do you think? What kind of test will be this one? Okay, Z-test. And which kind of Z or T test? One sample. Okay, one-tailed. Okay, and one sample, right? One sample. So because the only sample thing we are taking is this one, checking it with a hypothesized value called 50. So it's a one sample, T or Z test, whatever you call it. I'm just using the word T, that's it. Yes, one sample T test. Because T and Z are exactly same. The only thing is, the number of sample size, it depends, right? Both are one and the same at the end of the day. So based on the sample size, your software will decide. So the reason why I'm calling t-test is the function that I'll be using goes by the name t-test. Whether it is T or Z, the software will decide it internally. So it's better to use the word T because that way you can remember the function names easily. That's it. Right? So it's a one sample t-test. Fantastic. All right. Fair enough. Second question. The last campaign was successful in terms of credit card usage. Campaign was successful in terms of usage. Campaign was successful in terms of usage. What does that mean now? There is no this year, that year. Yes. So these are the columns that I have. Post, pre usage, post usage first month, post usage second month. What do we do with these? So I have pre usage. I have 1 month post, and I have 2 month post campaign. Pre-campaign, 1 month post-campaign, and 2 months post-campaign. Okay. Now, how do we check whether credit card campaign was successful? How do we check it? Pardon? Pardon? Mean of these two should be more than 50. Why?
Variance of all these three.
Pardon?
Variance of all these three data.
Variance?
Yeah.
Okay.
It's higher or low. Must be low.
Okay. Or anything else?
Too much post-campaign should be more than the user of 2 months post.
Should be more than what? Pre-campaign. Okay. Okay, you're getting a little bit close to that. Anything else? Can anyone modify her definition? Her definition is close, almost correct. Can anyone clearly tell me? Just think and tell me.
2 months post-campaign should be very low, but across 2 months and 1 month should be high. Again, across 1 month and pre-camp should be high.
What should be high?
Variance should be high.
Okay, we're coming into the terms of variance. Fine, I would not agree with that. Variance is no way involved in this. There is only means involved in this. Come on, guys, just try out. Just see where I mean, like try to get the business sense out of this. You will understand what is going wrong.
We have 2 months post-campaign.
Okay. Mean. Okay. Now. Online guys, come on. Prerna, yes, please help us out. What should we do here? Uttam? Any suggestions that you can give? Significant difference in new mean. Yes, Siddharth? Okay. So new mean as in, can you please explain it a little bit more? mean after first month post campaign, yes, should be different from which one? Pre-campaign. Fantastic. So let's do this. How do you say campaign was successful? Why do you do campaign in the first place? Please understand that. What do you want to see in campaigns?
Issue of sulfur use.
What do you see in campaigns? What do you do in campaigns? Promote sales, yes? Which means what do you expect? What effect do you expect in campaign? More number of sales? The sale value should increase? Yes, that is what we expect. Yes or no? I hope I'm not wrong. Right? So in this case, Tony, specifically in this case, for the existing customers, if I'm running a campaign, what am I expecting? I'm expecting them to spend more. The usage should increase. So, what should happen? Pre-campaign, mean of pre-campaign should be significantly different from post 1 month and post 2 months. Yes? So, what do we see here? Pre-campaign should be less than, or if you look at it another way, post-campaign should be greater than pre. Right? That's when I'll say this entire thing is successful. Yes. So now let's define for question number 1 and 2. Now let's define a null and alternative hypothesis. What is my null hypothesis here? In the first question, credit card usage has improved significantly from last year, which was 50. So what should I say? Present month usage, latest month usage equal to 50, which means there is no change. What did I tell you? You, sir, you. What did I tell you? It's not that your statement has null hypothesis. Equality should be your null hypothesis. So, your null hypothesis is latest month equal to 50, which means no improvement. Agreed? Alternative is latest month usage. Now, I'm specifically looking for improvement. So, instead of bluntly saying not equal to, I'll specifically say greater than. Fantastic. Which denotes that there is improvement. Right? All right. Here, what should I do here? What is my null hypothesis? Yes. Post 1 month equal to pre, which means no effect of the campaign. Is that understood? And this one, post 1 month should be greater than pre. Good effect. Good effect in first month itself. Now, why do I have the second month thing? Do you really think campaigns will be magically successful? We'll have to wait for the effect, right? Yes or no? You'll have to wait for the effect. Just like doing this course doesn't guarantee you a job, right? You have to prepare and you have to apply and wait for it, right? Suitable opportunity should come and you should be prepared to crack that. So usually campaigns, they are not successful magically. You have to wait to see the effect. So that's the reason why I written good effect in the first month itself. So that's a miracle actually. If my alternative hypothesis is correct, null is somehow rejected, then I'll conclude that the campaign was successful in first month itself. Now let's check it the next month. Let's say in first month it was not so effective. First month, let's say we are accepting null, which means there is no effect of the campaign in the first month. Then we will go for the next month as well. That's the reason why I have been provided with 2 columns. So post usage second month equal to pre, and post usage second month greater than pre. So no effect of the campaign even in second month. That's a complete failure of the campaign. That is what we will conclude if both the nulls are accepted. If let's say this null is accepted and here the null is rejected, we'll say although there was no effect in first month, right? Good effect in second month now. Good effect in second month despite the failure in first month. This is what I will conclude if this has to be my alternative hypothesis. And here, no effect of the campaign even in second month. So overall campaign failed. That I'll write it down here. So overall failure. Agreed, everyone? That's an overall failure, right? Alright, let's look at the next question. Is there any difference between males and females in terms of credit card usage? Ooh, what kind of a test is this? Males versus females usage. What kind of a test is this? Independent sample t-test. So what we will be looking at? What is my null hypothesis here? Male spent equal to female spent. What do you conclude? No change in the behavior of credit card usage, or both are having same usage patterns. Male spend not equal to female spend. A difference in the spends, right? There is a difference in the spends. All right. Fourth question. Ah, that's a good question. Which column should we be doing this one?
Latest month.
Exactly, latest month. That's the reason you have latest month. In the latest month, how are these people behaving? Did I use the word campaign here? So there is no question of post or pre campaigns, right? Fourth question. Is there any difference between segments of customer in terms of credit card usage? Ooh. Segments of customer and credit card usage. And let me tell you, there are like three segments. Segments 1, 2, and 3. Yes. And the credit card usage. What should I write here? What should be my null hypothesis? In segment 1, the average spend, I'm just taking an average here. I'm just considering average, which is okay to consider. So segment 1 average equal to segment 2 average equal to segment 3 average spend or average credit card usage. I told you about F-test, right? You can have a variation of it, right? The ones which we explained with variance, it has a different formula. The ones which you are doing now will have a different formula, internal formula, the statistical formula. The function will be one and the same. Clear? See, I told you, right, that but the basic definition is with variance. And the basic definition is with your measures of dispersion. And F value is calculated based on your variance or standard deviation. That is with the F value. But I have also said this definition can be tweaked. We can check whether like something like mean equal to 0 or mean equal to hypothesized value, like mean of A equal to B equal to C, which is all overall equal to some value, right? So like if I have like this, beta 1 equal to beta 2 equal to beta 3, overall equal to 0. This I can check. Or for example, beta 1, beta 2, beta 3, all the things not equal to 0. This is also one variation of F-test. Like beta 1 not equal to beta 2. Yeah, this is also a variation of F-test, right? There are more than 3 groups that we are looking at. More than 3 samples that we are looking at, right? This is also an F-test. But yes, exactly, the name ANOVA itself means analysis of variance, right? So that's your basic definition, but I said it can be tweaked. That formula can be tweaked, right? Okay. And alternative hypothesis is all these segments showing a different mean. The mean here is not equal to the mean in segment 2. The mean in segment 2 is not equal to segment 3. Right? Now, there is a small concept that I want to discuss here. Let's say we are taking one continuous variable y. Right? You are checking with respect to, you are writing an equation with respect to x1, or like as a function of x1, x2, x3 and so on, right? Where y is continuous, x is categorical. All the x variables are categorical, right? This is one way which we do, yes. Or there is the basic way that we have been discussing till now. We have y as a function of one variable called x, where y is continuous and x is categorical. Yes or no? So here there is a difference of number of categorical variables. Here there is only one categorical variable. Here there are multiple categorical variables. This is known as one-way ANOVA. This particular thing is known as one-way ANOVA. This is your regular ANOVA. Two-way ANOVA, or you can just call it as regular ANOVA. You simply use the word ANOVA for this. There is no specific word for this. But this is specifically known as one-way ANOVA. Why I am saying this is there is a function which goes by the name one-way ANOVA. So you have to understand why we called it as one-way ANOVA. This is the reason why we are calling it as one-way ANOVA. That's clear? Every one of you? Is this clear online, guys? So if my question is what kind of test we are doing here, you would be saying we are doing one-way ANOVA test here. Is this clear to you, all of you, online guys?
I have a clarification. Can you please explain what exactly is one-way ANOVA? When we do this two-way ANOVA, or whatever it is that is called here, we are comparing groups. In one-way ANOVA, what groups are we comparing? There is only one, right? The continuous variable is y, and x is your categorical variable.
Did I say group? I said variables. So y is variable, x is a variable. So y is one variable, x is one variable. Is that clear, Uttam?
Okay, got it.
So hence that's a one-way ANOVA. Here y is one and x is multiple variables, multiple categorical variables. x1, x2, x3, all categorical variables. Right? Is that clear now, Uttam?
Yes.
All right. Fifth question. Is there any relationship between region and segment? Oh. Finding the relationship between categorical variables, region and segment. What test we do here? Chi-square test. That's it. Region versus segment. That's a chi-square. Last question. Is there any relationship between card usage in latest month and pre-usage? Credit card usage latest versus credit card usage in pre-usage, pre-campaign usage. Both are what kind of variables? And between two continuous variables, what can we find out? Correlation or linear regression or whatever. Right? Let's do one by one. So first things first, importing packages, and here is where I have to introduce you to a new package called SciPy, Scientific Python. If you please look at that line that I have highlighted there, I have imported a package, a sub package called stats, and this is what I need. That package contains a lot of statistical tests, a lot of statistical functions, and every one of those I'll be using in my upcoming classes. Clear? All right. Pardon? Math is for few of these functions like square root and all these things. That's an inbuilt package, like one of the base packages of Python. You don't have to install it separately. If you're installing Python, you'll get math. SciPy is something which is you have to install, or it comes through Anaconda. Base means which is coming purely through Python installation. Like you download that 60 or 70 MB of Python, you definitely get this math package. SciPy is something you have to pip install. Or maybe if you are getting Anaconda, you'll have SciPy by default. So I'm reading this data, and if you look at the head of it, you can find these columns. Yes, these are your columns. So on an average, at this moment, customers are spending close to 63.17 per month with a standard deviation of 11.24. Right? This is what it is. Now, as we all decided, the first question is one sample t-test. Yes or no? Yes. Now, please, everyone pay attention to the function that I have used here. From stats package, the function is t-test. That's the function. T-test one samp. Right? So, stats.t test, I have one sample, I have independent sample, right? And I have two sample or relative sample, rel for relative. Two groups which have similar behavior. Ind as an independent sample t-test. Two samples which are, two groups which are mutually exclusive. Is that clear? Those are the three functions which we have discussed before as well, right? So this is what it is. So A happens to be my actual input. My hypothesized mean is 50. So this is the question, right? Card usage has been improved significantly from the last year usage, which is 50. Comparing credit card usage of post-campaign 1 month or latest month, whatever this hint is a little bit incorrect over here. You can use latest month usage. You have to use latest month usage with last year value of 50. So A is equals to latest month, population mean is equals to 50. I'll run it. Please look at the output. What is your test statistic here? Which score is your test statistic? It can be T or Z score. That's your test statistic. What's your p-value? It's not 2.4. It's 2.4 into 10 to the power minus 39. 2.4 E minus 39. E, what is E? 2.5 E minus 10. What does this mean? Guys, what does this mean if I write something like this? 2.5 into 10 to the power 10 to the power minus 10. Yes or no? So what value we have got here? 2.49, let's say, into 10 to the power minus 39. It's like 0.000000 after 7 zeros, you have 24. Very big value, right? Very low value. If P is low, P is low, means So guys, what is the P value here? P value is very low, right? Yes or no? If P value is very low, then what should I do with my null hypothesis? I should reject my null hypothesis. So what is my null hypothesis here in this case? Equal to 50. What does that mean? Yeah, latest month usage equal to 50. What does that mean? No improvement. Are we accepting the statement? No. What is your conclusion? There has been a significant improvement in the, right? that thing you have to describe here. This is one thing which I have not done it for you. I'll give you this case study. You'll have to describe everything with complete details. Right?
Can I ask a question? What does the statistic tell you? What statistic is it?
It's a T value or Z value. T score, Z score, we have calculated it, right? That is what is your test statistic.
Oh, I see.
That's
okay.
it. Now, can we tweak this function? Can we tweak this function? T-test. Stats dot T-test. Can we tweak this? Yes, guys. Is there any way how to tweak this? So this is what you have to look at it. What kind of tweaks can we do here? Change the confidence interval. What is your default confidence interval? 95. Default alpha is 0.5. That's your default alpha. Change this. 0.05. I'm so sorry. 0.05. I'm so sorry. Your default alpha is 0.05. Just try to change this. And second, of course, write descriptions. Write proper descriptions. So this is what you are going to do as soon as you go home with this case study. Anyways, I'll be sharing the solutions, right? So you have to write your proper descriptions for this. Second question. What is the second question here? The last campaign was successful in terms of credit card usage. So may I know what we can do here? We have to check 1 month post with pre-campaign. So let's do that. What kind of a test is this? It's a 2 sample or paid t-test. So if I'm just printing the mean of these two, one is 52.23, the other is 58.05 for pre-usage, post-usage second month. And if I also can print post-usage first month, let's look at all the 3 together. What is the column name here? Post underscore usage 1 month. Okay. So capital P. Right? What can you say from these means? First one, that might not have improved much, but 52.23 and 58 might be there is an improvement. Right? So we have to check if 52.23 is significantly different from 52.7 or not. They are anyways not equal, right? 52.2 and 52.7, they are never equal. They are different, but how different? Different by a big value or just slightly different? Is this just a coincidence that your value has increased, or is it the actual effect of the campaign? I have to check that. Let's see.
You can say that something is significantly different is depending upon judgment, right? If it's a pharmaceutical industry, then slight difference will be significant difference.
Then if everything is based on judgment and intuition, why do we do data science then?
But if I compare it in the pharmaceutical industry, when you just compare minute numbers, also difference.
So that's the reason why, that's why I said, like in pharmaceutical industry, your alpha is always set to 1. You're looking at 99% confidence interval, right? That's the reason why we do that. Yes, you are absolutely right about it. It's not like sales figure where you see significant bigger numbers, at least from the naked eye, right? In pharmaceutical industry, the numbers difference is not that significant, but still you have to prove that both are same or different using your test, right? All right. So what should I do? First, I should run a 2 sample t-test, right? Stats dot t-test. I'm running t-test underscore rel for relative, where my first argument is customer dot pre-usage And the second argument is cust dot post usage first month. First I'll check those two, isn't it? Before and after. Please look at the p-value here. What is the p-value? 0.38. Is 0.38 greater than 0.05? Yes, it is greater, right? So what should I do here? Accept null hypothesis, isn't it? P-value is high, null gets accepted, right? You don't go with those definitions, especially you. Anyways, so what was our null hypothesis here? If post equal to pre, then what is our thing? No effect of the campaign in the first month. So what do you conclude here? No effect of the campaign in the first month, right? And let's look at the next one. T-test relative for pre-usage and post-usage second month. What's the p-value here? It's not 4.2, everyone. It's 4.2 into 10 to the power minus 16, which means 0.000 after 14 zeros, 42. Right? This is exactly like my salary hike last year. This is the hike that I have received. So, what do we do with our null hypothesis? We oh, mommy. Online guys, what should we do with this null hypothesis here?
We fail to reject the null hypothesis.
Pardon?
We fail to reject the null hypothesis. Oh, sorry. If p-value is low, we'll reject the null hypothesis.
Alright, we reject the null hypothesis, everyone. Yes. So if you're rejecting null hypothesis, what do you conclude? Good effect in second month despite the failure in first month. That's it. Right? Next one. Is there any difference between males and females in terms of credit card usage? Ooh. Is there any difference? Let's see. So I'm just taking male spend and female spend. So you know this basic subsetting, right? So just to give you a perspective, dot lock. Yes, I hope it's clear now. Yeah. So I'm just taking male spend and female spend. I don't know who wrote this one. Okay. Oh, why do you think this is giving me a syntax error? Print, I'm missing a bracket here. The codes that I have written is from Python 2. So that's the reason why, even if I am not using dot lock in Python 2, still it was giving me an output. So I have to change it in perspective of Python 3. Right? So this is my male spend, this is my female spend. So I'm just calculating the mean of male and female credit card spend. Just the mean of it. Yeah? Oh. So the insert is on, yes. Okay. 50 and 54, they're of course looking different, but are they significantly different? If just imagine if you're taking 50.12 as your central line and you're setting your confidence interval at 95%, you'll just see if this 54.99 is lying between that confidence interval or is it lying outside the confidence interval. So what do we do here? We do t-test underscore end for independent sample. Now, there are two things which we have to look at it. Please Listen carefully. This I have just included as an error case, but just look at this once. I have said equal variance is equals to false. I'm looking at the means, but I'm firstly assuming that the variance is not equal between males and females. Both are having different variance. Yes? See, different variance means, like if I look at the average of all the values of males, right? So individual values of males will be closer to the overall average of males and females. And the overall variance in males will be different from overall variance of females. So that's why I have assumed equal variance is equals to false. I have assumed it. To prove it, what I'll do is, I'll run both the tests. First, I'll assume equal variance is equals to true. Both are having equal variance. Next, I'll run the same test where I'm saying equal variance is equals to false. Now, please look at it, everyone, carefully. This and this. Right? Now, the test statistic for both the things, one is minus 3.7, the other is minus 3.6. Mathematically, both are almost same, right? I mean, like, it's not like one you are getting it as minus 20, the other is minus 3. It is not that case, right? It's almost same. Just look at the mathematical figure, that's it, not the statistical confidence interval figure. Normal mathematics, right? So if this is the case, then I will assume that variance is equal. So I'll just go with this one. Equal variance is equals to true. I hope you're able to understand it, right? After running both the tests, after running the above two, if the score or statistic, test statistic in both the cases are almost same, then anyways running any one of these things is same, but then we conclude that variance in the two groups is equal. I hope you're able to understand what I've written here, right? Else we will say that variance is not equal and we'll remove this one. Clear? And anyways, let's say if this is coming as minus 10 and this is coming as minus 3.6, you'll also find a huge difference between p-values. You might observe that one p-value might be high, the other p-value might be low. Yes, we don't know, but still, so that's the reason why we are looking at this statistic. Yes, and in that case, we will assume that variance is not equal. Equal variance is equals to false. Right?
Normally, there is nothing to do with variance in the test.
No, it has to do actually. You have to look at the variance as well. So the internal formula changes. Like if the variance is not equal, then you will have to assume that you will have to fix to this particular option, right? I hope you are able to understand that. So, no? See, we are looking at average spend of male and average spend of female. So let's say the value here is 50 and 54, right? So somehow or the other using t-test, you will be proving that 50 is significantly different from 54 or not, right? But what kind of data have you taken? Okay, in this case it is male and female, so you might not have any business context of equal and unequal variance. Let's look at that example. We have two groups of spend people. One group is spending 0 to 1000, the other group is spending 1000 to 2000. So all the points should be close to 1000, isn't it? So that's when your variance factor comes into picture. So that's the reason why they have given this option in the first place, right? They have to, right? Yeah. We'll reject the null hypothesis. You're absolutely correct. P-value is very much low here, 0.00034. We will reject our null hypothesis. And what is our null hypothesis saying here? My null hypothesis says male spend equal to female spend. No change in the behavior of credit card usage, but the statistical test is telling me the other thing, that there is actually a huge difference between the way how a male and female spend or use the credit card, right? That conclusion you have to write here. Next one, segments and credit card usage. So here, as we have decided, we will be going for one-way ANOVA. Yes? So please look at the function. So this is your segment counts. And first of all, what I'm doing is I'm taking all the three segments, S1, S2 and S3. So from customer latest month usage, where cust segment equal to 1. That's a basic subsetting, right? Series subsetting. From latest month usage column, get all the values where cust segment equal to 1. It's like select latest month usage from cust where cust segment equal to 1. That's the meaning of the statement. I hope everyone understands this by now, right? It's just that it is missing dot log. Dot log and dot log. Why am I not putting comma inside? Because cust dot latest month usage is a pandas series, right? It's a one-dimensional. So the function is quite simple. F underscore one way. Stats dot F. This is your F test. This is your F underscore one way. And what are the three samples involved? S1, S2 and S3. That's it. This is your F statistic, F score, and this is your p value. And what is the p value here? P value is 0.0000 after like 10 zeros you have 7, 3. So what would we do? We would reject null hypothesis, right? And what was the null hypothesis saying? All the three segments have equal spend. So what do you conclude here after rejecting null hypothesis? What do we conclude? Yes, there is a significant difference in the spends of the customers in the three segments, right? I hope that is clear, online guys. Is that clear, online guys? Okay. So even if you look at the means, okay. All three are significantly different. This is what it means. Now here, let's look at the chi-square test. So I have cust segment and cust region. So see, I have done a crosstab using pandas.crosstab, and I'm saving it in a variable. So I'll call it as crosstab. Yes, I'm saving it in a variable. Yes. Now I'm performing a contingency chi-square, there's a generic chi-square, Pearson chi-square test on my observed values, which is coming from chi-square table, xt chi-square table, right? So let's run it. So if I can say this first value is your chi-square. So the of all the output, if you can just look at the help of it, it says like it returns the chi-square value, the p value, the degrees of freedom, and the expected observations, expected frequencies. We had calculated it in Excel, right? So this particular function gives me these four. Let me just copy that there, so that it will be easier for you to understand. If you look at this output, this is what the output means. Right? So this is your chi-square value 16.60, p value 0.05. It's a borderline case actually. Your confidence interval is 0.05, your p-value is 0.055. Right? It's a borderline case. You have got 9 degrees of freedom here, and this is your expected array. Expected values. So for all these values here, this is your expected values. Clear? So what should we do with our chi-square test? The p-value is almost same, right? Almost same. So I'll say there is a little influence, a very little influence. Yeah, so the p-value is equal, right? The p-value and the degrees, the p-value and the alpha are equal, right? So I would say yes, it is a case where we are saying, we are concluding that yes, there is a slight influence. Yes, there is an influence, but it is very low. Had it been a value like where I have got my p-value to be 0.3 or 0.4 and my alpha is 0.05, I'll say there is a strong influence between these two groups. Here I would say yes, there is an influence, but there is a very weak influence over here. This is what I'll conclude with this chi-square test. So if I consider y to be my one of my variables here, let's say segment, and x to be my region, right? So are they dependent on each other? Yes, but slightly, to a very less extent. Okay. Last is correlation coefficient. You can go for a Pearson correlation or normal correlation coefficient. Yes, or you can discuss regression. This problem we can discuss it during the linear regression class. Now I want exactly 15 minutes more of your time and your participation as well, without which this entire conclusion can't be given, right? Introduction both. Tell me one thing. According to you guys, let me use this sheet here. Now recording is on, Vishaka. Now according to you guys, that doesn't mean that you log off now. 15 more minutes. Now, what do you think? What are the common business problems people face?